going to use an example of a real life situation, and you don't need to draw what I'm drawing yet. I will tell you what you actually need to draw once we get there. So, it's February. At this point, people know by now that they're not supposed to have earbuds in their ears when I'm teaching them stuff. I mean, we know it at this point. It's not brand new information. It isn't something that nobody, this is every class, every teacher on the planet could complain about this. It's not like you guys don't know. Some days, I'll be like, hey, boo, take them out. Some days I'll make a little gesture, while I'm teaching and just move on. And some days, frankly, I'm just so beat down and tired that I just don't even deal with it. It just depends, which is obviously the wrong way to do it. So I've decided it's February, almost March. I'm not doing any of those strategies anymore. I am going to go to Amazon this weekend, and I am going to buy myself a little catapult that shoots water balloons. What? Do we all know what a catapult is? Okay. So one of those little, it's on a lever.
Oh, I thought you were actually getting on someone for having a...
Here's me. Here's me. I'm sad, boo-hoo, because people are still crying, still have those are my tears and my red hair. Me sad that somebody is still denying themselves, all right, an education because they got earbuds in when I'm trying to teach them. Here's me crying. But instead of complaining or hand gesturing or anything like that, I'm going to literally walk over. I'm going to put it right here in this corner. I'm going to dig myself a little trench where I'm going to stick it with a little foot lever, and I'm going to go without even saying a word. And then, bam, those little water balloons are going to go up.
They look like birds.
So how's this going to be?
They're going to be orange because orange is my favorite color.
You're not actually serious, right?
And here's the culprit. Some anonymous kid.
Cameron, where are you?
Kyle.
Sad because he's not getting an education, but he's just sitting there listening to his music, and bam, he is going to end up getting splashed with a water balloon. Now, notice it doesn't actually hit him in the face because, let's be honest, JCPS is on the news enough. I don't need to hit somebody in the face with a water balloon, so I'm just going to kind of give you a little shock by putting it at your feet. So you don't need to draw my lovely little diagram here, but what you do need to have, you can if you want to, but what you do need is this shape that I drew right here. Okay, what shape is this? This is a parabola.
What is a parabola?
A parabola is any shape. It's that U shape.
So what do I need to draw?
So all you really need to draw is this. That's all you really have to draw, is the upside down U. If you want to add the decorations, you can. Or if you just want to watch this video later for your amusement, you can do that too, so you can see where it came from. But so anytime that you are dealing with a little U-shaped graph, you are dealing with a parabola. So when I'm trying to decide whether or not my plan is going to work, okay, what are some things I need to take into consideration? So before I go home and spend my hard-earned money on Amazon, because these things really do exist, I could go buy one tomorrow if I wanted to. What are some things I need to keep in mind?
How the janitor feels about this?
Ooh, okay, that's an answer I haven't gotten today, how the custodian feels about that. I can guarantee you Angel would not be very happy with me.
That's her
yes,
name.
that's her name. So that is definitely one thing that I need to take into consideration. What else? Yes, ma'am.
Where the student is and where the capital is.
The ceiling.
Beautiful. Oh, so hold that thought. Okay, so the distance, obviously, between me and the student, right? Okay, I also need to know the height of the ceiling. What happens if it goes up too high? Let's say I'm aiming for Nia, and I shoot it too high, and actually, let's be real. I'm aiming for Evan. I hit the ceiling, and what happens if it goes too high so that it hits the ceiling?
It'll pop and land on Christian.
It's going to hit Christian, who was not my intended target, right? So there are factors that are important. So one of those factors is obviously the height. So far, all you had to draw was the little parabola shape. Here's what else I would like you to draw. A little imaginary X and Y axis.
Oh, okay.
Okay?
This is where this gets boring.
This is shut your pie hole. Okay, so for one thing, we need to consider height. So we're going to go ahead and label the y-axis as height, because clearly that is something that is very important. So anytime you are dealing in the real world with something that goes up and comes down, which is a whole lot of things, because let's be honest, we live on planet Earth, right? Lots of stuff goes up and gravity pulls it back down. So we're talking about a lot of real life applications that have to do with this, whether it's fireworks, whether it, Thunder Over Louisville people, they need to know, they need to make sure that the fireworks go high enough, everybody can see it, but they don't take out like a UPS plane, for example, right? If you're planning on bombing some country you're at war with, you probably want to make sure that, the bomb hits the right spot. So there's lots of logistics that are involved in this kind of thing. Of course, we're just talking about a little mundane water balloon problem. So aside from height, something that people don't usually bring up, so I usually have to bring it up myself, the other factor I'm thinking about today is time. Because what happens if, Evan puts those earbuds in, and it takes a full, 20 seconds, I want to make that impact instant. The second they go in, I want them to know, bam. Ooh, it's like smacking the kitten, right? When they scratch your stuff. You want them to know right away, no, bad kitty. Okay? So, no, I don't really hit my cat. Okay. So, time is also a factor. If Evan puts his earbuds in and doesn't get hit with the water balloon for another 30 seconds, then maybe he won't realize. He's like, oh, I just got hit with a random water balloon. We want him to notice. I put the earbuds in, and then bam, I got nailed. So that you associate one with the other so that you get trained not to do it anymore. So time is also a factor.
I actually thought you were being serious.
So how long it takes to get there.
And in the situation say you're throwing.
Right. So one of the things that you can do, so we obviously, for a variety of reasons, need to figure out what the height would be, and we need to figure out about what distance it would travel or how long it's going to take to travel. So in the real world, what they actually do, whether it's bombs or catapults or fireworks, is they go out and they field test things. They take it, they do a bunch of tests, preferably in a non-populated area or in a lab somewhere, and they do enough experiments that they can figure out pretty reliably how high it's going to get. You can't possibly win.
I swear to
What?
God.
This is a really cool car. And then all of a sudden it became collectible. So what happened once the price bottomed out? Somebody decided that now it's going to be a collectible.
It went up.
The price started going up. So any time that you're dealing with collectible objects, for the most part, not always, but frequently, the price will have a tendency to go down at first until somebody decides that it's a collectible, and then the price starts to go up. Another way that you could tell by looking at this equation that would happen is that right here, notice that your leading coefficient is a positive number, right? Positive is happy. That means it's going to be a happy parabola. That means that it's going to open upwards. So all of these things, all of these pieces really do actually have meaning. It's not just gobbledygook that's thrown in there. You really do use this stuff. Yes, sir. I hope, why would it matter in a case? So it's pretty obvious why it matters where the maximum would be. Fireworks, you obviously want to know how high it gets, stuff like that. Why would somebody want to know where the minimum would be in a situation like this?
You know how much money they lose before they actually make it?
There you go. You want to know, hey, is this going to be a good deal, right? Where does it bottom out so that I know whether or not I'm getting a good deal? Okay, so for various reasons, you might want to know that minimum. Bless you. Okay? So we are going to actually practice how to find the maximum and the minimum for various quadratic functions. But these numbers are pretty messy, right? Real life numbers have a tendency to be messy. So we're going to practice finding the maximum and the minimum with some quadratic equations that are a little bit less messy to start, okay? So on that same piece of graph paper, I'm going to walk through. Go ahead, just underneath that real life example, draw yourself a little X and Y axis, please. I know I'm talking a lot. I promise I'm almost done.
That's how I feel.
You gotta have a lot of energy.
So draw yourself a little X and Y axis, about 10 by 10. And then we're going to find the maximum or the minimum, I don't know which one we need yet, of that quadratic equation. But we're going to do it with easier numbers, which was why we're doing one that's more basic.
Is photo math gonna come into play?
I don't know if photo math does this. That's a great question. I don't know if photo math will do this for you or not.
I don't think there's something in photo math.
So all you guys need is a little X or Y axis. So first of all, we need to determine whether we're going to have a maximum or a minimum in the first place. So I'm going to look at my lead coefficient. Is my lead coefficient a positive number or a negative number? Okay, this is positive. So that means I'm going to have a happy parabola, right? So when I get done drawing it, it's going to look a lot prettier than that. But we know that when we get finished drawing it, it's going to open upwards, okay? So that's one thing that we know. But now we need an exact coordinate to represent that minimum, okay? So here is how we're going to get it. So, because my lead coefficient was positive, so this has a minimum to it. That's what we're looking for. A minus 16x, yes. So 2x squared minus 16x plus 33. Sorry, honey. So because the lead coefficient is positive, I know that this parabola is going to be a happy parabola. It's going to open up. So we know it's going to have a minimum to it. So now here's the procedure for how we figure out what the minimum is going to be. This is something you have not learned yet. The first thing we have to find is the x coordinate. And in order to accomplish that, there is a formula that we just have to memorize. I would suggest, I cannot stress enough, how much you probably want to get yourself some flashcards for this unit that we're doing. There is a lot to memorize. There is a lot of vocab to memorize. There are a lot of formulas to memorize. Ask your friends that are in AP, that are in Advanced Geo. Ask them about factoring and graphing quadratics, and a lot of them are probably going to say, ooh, you got to remember a lot.
Is it hard?
Okay? I wouldn't say the word hard. There's just a lot you got to know. If I were you, I would invest in some flashcards. Okay? So one of the things you have to memorize to start is the same way that there is a generic form for like slope-intercept form, for example, right? Y equals mx plus b. There's a generic form for an equation that is a quadratic equation. And I'm going to write it above this one. It's y equals a x squared. So a, in this case, is the number in front of the x squared plus b x. So in this case, b is that coefficient in front of the x. And if we use A and B, we probably use what? C, exactly. We also use C, and C is that constant. Remember how I told you standard form last unit wasn't very important? The reason standard form is important now is because that exponent with the 2 has to come in the front, or else it's going to screw you up when you're trying to graph it. Because A, B, and C, which letters you use matter, okay? And it is basically just some old white dude discovered or invented or whatever you want to call it, the formula for how you find the x coordinate of the minimum or maximum. That formula is the opposite of b divided by 2 times a. You just kind of got to memorize that formula. The opposite of b, or what most people will say is negative b. I like to say opposite because of examples like this, actually. So just like when you're doing like y2 minus y1, that minus is part of the formula. So minus, what's my b in the example that I have up here?
16.
What kind of 16? It's a negative 16. So it's a negative 16. That's why I like saying opposite of b instead of negative b. A negative is going to turn this into a positive 16. So I'm going to go ahead and take care of that. because I already know that negative negative is going to become a positive 16. And instead of 2 times a, I'm going to do 2 times,
33.
what's my a up there?
2.
2. My bad. So 2 times 2. So 2 times 2 is obviously 4. So the x coordinate for my maximum is 16, my minimum is 16 divided by 4, which is a 4. Oh my Jesus, what is happening out there? Okay, can you graph a coordinate with only an x coordinate? No. You also need a y coordinate. In case you haven't noticed, these problems are basically like so much that you've learned, like all in one big giant problem. It's like order of operations mixed with memorizing a formula, mixed with algebra, mixed with all kinds of stuff, graphing all into one. So now that we've got an x coordinate, we need to get the y coordinate. How am I going to get the y coordinate?
Blood substitution.
I'm going to substitute. See, we got substitution thrown in there too.
Wait, really?
Yeah, really.
Oh, I was just shot in the dark.
Oh, well, your shot in the dark worked. So we're going to take that equation from the top. So y equals 2x squared minus 16x plus 33. I know, it's a lot. I know. And we're going to take that x coordinate and we're going to substitute it in for the x's. So instead of x squared, this is now going to become 4 squared. Instead of 16 times x, this is going to be 16 times 4. And you still rewrite the rest of the equation, just like substitution. You just rewrite the whole rest of the equation around it. So you just memorize the formula, opposite b divided by 2a. Then once you get that x coordinate, you've got to take that x coordinate and substitute it in there to find your y coordinate. Now here is the most common mistake that I see kids make. They do this wrong. They do 2 times 4 and they get 8, and then they do 8 squared and get 64.
No.
Order of operations, what are you supposed to do first?
The exponent.
The exponent.
Oh, parentheses.
Exactly. So I've got to do the 4 squared first. So 4 times 4, 16. 16 times 4, 64.
32.
So we've got 2 times 16 is 32, minus 64 plus 33. So our y coordinate is now going to be 1, right? Yeah. So I just did all that flipping work to get one coordinate of the parabola, to get the minimum. So my x coordinate is a 4, my y coordinate is a 1. So that means the corner of my parabola, the minimum, is at 4, 1. So over 1, 2, 3, 4. So the corner is right there, right? We also know it's a happy parabola, so we know it's going to open up. Sure would be nice if I would let you just kind of sketch and be done, right? Darn it, not going to let you do that. But I'm not going to cram any more information into your brain today, okay? What I am going to do, though, is show you an amazing music video to help you remember the formula
It's gotta be cringy.
for, oh, it's not cringy at all. So not cringy. So it's, oops.